Hi, everyone, and welcome to the MLOps podcast. I'm Dean, your host, and today I have with me Dror Haor. Dror is the CTO at SeeTree, where he's building an AI enabled system to track tree attributes in agriculture and forestry. And he also holds a PhD in electrical engineering, focusing on neuroscience and machine learning. Dror, thank you so much for taking the time to speak with me today.
Yeah, thank you, Dean, for calling me. Yeah, thank you.
Awesome. So let's start at the top. What does production in machine learning look like at SeeTree?
Yeah, that's a great question. I think I'll start by introducing a bit what Citrix does, and that will help us all to understand how does production look. So Citrix is a company in the agriculture domain where mostly we're focused on helping farmers manage their farms better. What we actually do is we're taking remote sensing data. It could be like satellite data or drones, high resolution imagery or data from the ground or whatever. And what we actually do is analyzing this using AI models and providing our customers, our farmers around the world with this analytics data layer, which on top of it, we're going to take, we're doing more analytics just to make more valuable information that or application that can help the farmers grow their farms better. So it could be like uh, imagery data of trees that we can do the analysis and get how many dead trees you have there or missing trees you have there. We can see how fast the trees grows when we do this imagery over time. We can get imagery from the ground and get some fruit count, for example, if we're doing orange fruits, or even carbon sequestration if this is a forest. So analyzing this vision data in scale is actually what we do. And one other thing, I think it will be very important for us to understand how does production work in Citrix is that we're working with farmers, and in the agriculture domain, all the costs for products like us must be very very low. So we're working really hard on making sure that our products, our technology can work in scale, but should cost very very low dollars. And we'll talk about it more, I guess, in this talk. But this is something that is really important for us. And second thing that is important for our farmers is accuracy, because time is money, and this is for everybody. But human labor for farmers is really scarce, and they don't really have a lot of money to invest on all of some kind of machinery and robotics and things that everybody sees worldwide. So accuracy is really really important, and this is something we also need to make sure of, because when you have like 10 trees that are diseased in a block of 10,000 trees, so you need a 99.9 point accuracy. So this is something we will need to also talk about, I guess, here. So how does production, return to your question, how does production look in SeeTree? So what we do is we're taking those images as I said. It can be from different modalities or different sources, and we're splitting them. We're having first a map of the entire block or the farm, and we're using, first of all, a machine learning model to detect all the trees or all the entities within the farm. Then for each of those tree, we want to get a unique identifier that we can track over time. So for this, let's say, try to imagine you have a farm with 10,000 trees, and you have 10,000 entities like this, and you have an image, you have a point on each tree, and we have an image where the point is in the center of the tree. Now you need to analyze this tree, and you need to do this for hundreds of millions of trees like this. Okay, so this is production in SeeTree. What we do is analyzing this using AI. And as I said, we need to be very, very accurate. So we also incorporate human in the loop to make sure that our models are stay accurate and over time stay accurate. So the idea is that we're taking from each farm like this, which can have between 10,000 to 50,000 trees, for example. We have a technology, we have models that actually can do a very smart sampling of those very large set of trees, which I would say that most of them are very similar to each other. So when you when you try to ingest all of these trees, you see higher similarity, and then you can actually incorporate this into your learning to make sure that you can sample very low numbers. So out of 10,000 trees like this, we can sample a few hundreds, and those are used for human in the loop, human labeling. We're taking those labeling and comparing them to our models, and then we check the accuracy. And if the accuracy fits our standards, we actually can move this data to what we call to the farmer. We publish this to the farmer. But if not, we actually start a cycle of automatic retraining where we get the data that was labeled, get more data labeled for this farm, and do automatic retraining and return to the same point where we want to check the accuracy of the model. And this happens totally automatic. In most, like 99.9 of the cases, we actually solve this entire thing mostly automatically. But to ensure that the accuracy is very good, we incorporate this iterative flow. So this is like the general flow. We have different types of flows in production where things flows automatically, fully automatically to the customer and stuff like this. But I think in general, this is the main production cycle.
Amazing. So there's so many interesting sort of nuggets in what you just said. Just to name a few off the top of my head, I think that uh, the some of the unique things that you do is one that you have like sort of a sensor fusion, like you're getting different types of data about the same object and sort of melding them together to get more information. The second is that your end users are non-technical people, so they know a lot about their domain, but they don't necessarily know about machine learning as much. And you need to make that information accessible to them in a way that they find useful and sort of speaks their language. Another thing that you mentioned is that there's this sort of challenge around, on one hand, being able to provide the capabilities at a very low cost, but on the other, because of the scale that you're working with, the accuracy that is required is very, very high. And so you can't really ease up on any one of the sides of the trade-off, like performance versus cost. And the last thing maybe is related to this scale, which is I think you alluded to this a bit, but that uh, when you're running a model, you want to make sure that it was sort of validated and that you know that you're getting good results with high confidence. But the only way you could do that is if you have sort of a very smart way to sample the data and make sure that the data that you're actually reviewing with a human is representative of the data that you're not reviewing. Otherwise, you're going to get lost sort of in that mix. So those are a lot of very interesting challenges. I'm sure that a lot of companies have one of those things, maybe two, but few have all of those. So you're sort of in an interesting position. I guess maybe to start with the first one, I guess the sensor fusion and everything. Like, if you can share a bit about how you deal with the fact that your data, of course, it all is related to a tree, right? But it comes from different points of view. So maybe you need a different model for each point of view, and maybe each data point collected came at a different time and things like that. Like, what can you share about combining different sensors and making the most of that?
Yeah. So I didn't say, but we also incorporate in our system like hard sensors in the ground and weather data that we can use just to have more like a holistic view for the farmers that can actually, at the end of the day, can help them forecast how much yield they will get and those types of applications. So yes, so this is really interesting. I would say that in order to maintain like a closed circle around each tree or each entity in the world, we first of all we track those farms over time. So we do this every once a month, once 3 months, depending on the customer, and we can start seeing trends on the tree level. But we also have information like weather, for example, that is not coming in the same resolution, right? A tree is like a 5 by 5 meter size, but our weather resolution comes in like a kilometer by kilometer. So you need to incorporate all of those. So this is something that we built inside in our databases, which works at event level. So we have events talking to other events for the same entities. So a tree can have an event that can say, okay, it has a disease at that point of time. And then after a week, we have entered a new event, which is a new weather, for example, weather forecast or weather nowcast. And all those events are actually turned into like a time series for the same entity. And once we have this time series, we actually can analyze it at a more broader view for this and the same entity. So those, let's say, higher level of models or analysis that we're doing is actually taking advantage of this event level database, which is incorporated this is the like the low level, like the infrastructure of the system, but we have on top of it several layers that do analysis on this infrastructure. So this type of things help us maintain accuracy and also maintain like stability. Let's say for agriculture or farmers, when they have a hurricane in their farm, for example, and you didn't have any information from drone imagery at that point of time, but half of the farm is ruined. You must have these events entering your system to calibrate yourself. So this is a really critical point of our system. I would say also in regards to what you said that it's really hard to also maintain high accuracy with low cost. So our like the system that I described, which enable us to like sample part of the grove or part of the block and then validate ourselves, is a system that we've built in order to budget ourselves, because each customer wants to pay different price, because there's like a very large variety of different customers for SeeTree. Some of them are like very small farmers, some of them are very big companies, like $1 billion and more dollars companies, and those needs different product, different cost for their product. So this type of thing that we can sample amount of trees and then be more accurate, that gives us the ability to budget how much we want to spend. So if a customer wants more accuracy, we can tell them, okay, you can pay, let's say, 10 cents more, and you will get per hectare, not per total, but per hectare, and then you can actually get higher accuracy if you need it. So there's like a way to play with this accuracy bar, which is really helpful for us to give you a valid product, a valuable product for every customer that comes to us.
Amazing. So I'm going to dive into the pricing thing in a moment, but just to share, because I don't think I've heard the sort of event log formulated that way. So basically, what you're saying is solution for working with multimodal sensor data that's all associated with the same data point is that each data point has an event log, and that lets you attach different types of metadata because everything can be an event. Like an event can be a drone that flew over the tree and took a photo. It can also be a weather forecast. It can also be whatever sensors that are installed on the ground close to the tree. And that lets you both, I'm guessing, right, like at the model level, filter by the types of events that you want to pay attention to if the model only accepts a certain type of modality, but also get the temporal relationship between certain events and certain other events. So you, even if you're looking at a computer vision model, you might want to know the information and somehow feed it into the model that there was a hurricane the day before, even if it's not included in the vision data.
And
So I think that that's definitely a concept that could be valid for a lot of other people, even if they're not in the agriculture business. I think that we, like at DAGSA, we think about data very similarly in a different context. So I think that maybe event logs for metadata management are something that should be more popular than at least I've heard it to be. But thank you so much for sharing that. On the pricing side, so I'm not 100% sure I understood like how can you create different pricing tiers per accuracy? Is it just providing better models that are maybe more expensive, or is there something more nuanced to that?
so it's more simpler than that. We're training our models to be the most accurate as possible, right? We're getting the data, we're getting for each customer. We have the system, we can talk about it later, but we have the system that enables us to get a very accurate models for each use case and each customer.
Mm-hmm.
But then, all the time, it's not sometimes, it's all the time, there's some drifts. The data looks different, the trees get a different disease, the customer itself does actions on the trees themselves, they cut it, they do other things. So we need to manage all the time this dynamic situation for those images that we get. And the idea is that when a customer comes to us and say, okay, I can live with the 70% accuracy. So if we say, okay, for 70% accuracy, we need to get at least this number of samples. We need to get them right. And this will enable us to get to 70% accuracy in high confidence interval and stuff like this of the statistics. And then we can say, okay, then we can sample 100 trees of 10,000 trees, and that will work fine. But then comes a customer that say, I want to have like a 95%. And the model can reach it, but it's not always. Like if there's a drift, for example, then it might drift away, and for some blocks it will get 80%. Mm-hmm. So in that situation, we'll do this reiteration to retrain and to get the model to this 95%. So when we do this more iteration, it costs us more because we're having compute, we're having more man in the loop and stuff like this. But we can say, okay, this entire iteration is like very deterministic in that term, because we know how much compute we need how much human labor we need. So that cost us, let's say, $1, and that's is going. We're saying to the customer, okay, if you want this type of accuracy, you need to pay $1 more. Mm-hmm. So it's very flexible in that sense. So you can play with this. You of course you can opt in to 70% and then get 95%. That could be, but this is like the lower bar that they're paying for.
I see. So you're basically giving sort of performance guarantees at the lower bar. You might get more than that, but I think that maybe the interesting point here is that the pipeline that you've built is such that you get a base accuracy, and then you can improve that accuracy by adding iterations. And so in a sense, you're selling a premium for additional iterations to improve the model, which is a really nice concept, and also I think generally applicable So thank you so much for sharing that idea. For model customizations, because I know you mentioned this a moment ago, but I know we've spoken in the past. Like you're basically building or training different models for different customers and different sort of maybe crops and things like that. Can you walk us through the customization process for different models and how do you evaluate those new versions as they come along?
Yeah, great. First, I would say, just for the listeners that doesn't know how how it looks from like a bird's eye on a tree. Trees in South America, let's say even oranges trees in South America, doesn't look at all like the oranges in Israel or the oranges in South Africa. Uh, and the disease are different, the visibility is different, the way that the customer, the farmers are themselves treat those disease is different. So at the end of the day, because of this pragmatic market, what we do is actually we're having a system that maintain a model and of course retrain it all the time per region and sometimes even per customer. So each customer gets its own model, and for each customer, we are having this pipeline that runs through these models and make sure that it's on top of things, it doesn't drift and all. I would say that in terms of customization, we're trying to use rather the same architecture for all those models. I would say that from our side, it all those general models like SAM or Dino V2, Florence, and all those stuff didn't work. The modality is very different from what it's trained on, and we are ending up or training from scratch. We have a lot of data, so that's not a real problem with data, and or just fine tuning those models. So the idea at the end of the day is, of course, to do this fast, but we need to keep the model flexible. So because of those drips, because of those things that things looks different from season to season. For example, right now in Brazil, we have a situation where the sun is really high all the time, and that affects the images. So we need to make sure that we're on top of the visibility of the trees, and it's really critical for the models to enable this flexibility and training. And then what we have this architecture or several architectures that we're working with. And along those iterations that we talked about, when we do the second iteration, we're trying different types of models, and sometimes one of them wins, and the second one will lose, and maybe in the next iteration the other one will win. At the end of the day, what we want to make sure is that every drift that we found is solved, and the new model actually can work with, can solve it, can give a good solution and accurate predictions for every situation. So it's constantly changing, and we need to maintain an architecture that can work with this flexibility.
Yeah, that makes a lot of sense. I think one of the points that you made, which might have flown under the radar, but I think is really important. I actually was talking about this in the context of LLMs the other day. So I think it's very generic. It's not specifically for computer vision or agtech or something like that. Is that you need to have a good understanding of how far the data domain that you work with is from the sort of natural domain. And natural means different things for different data types. But usually, most of the computer vision models are trained on things like ImageNet. So if your data is images from the air of like forest canopies, that's not the type of data that the model was trained on, or if it exists in the data set, it's going to be a very, very small part of that. And the problem with those things is that a lot of times, the models, when you look at them, let's say from afar, they look magical and they do a lot of things that can help us sort of cut corners and get to results really fast. But when you look a bit more closely, you realize that that's only true if your data is within the domain of the main data set that the model was trained on. And
Exactly.
so what you're talking about is basically, first, this is something that you could solve a lot of pain for yourself if you acknowledge that early on. Like, you don't try to shove a model that's technically the same type of data into your product and then sort of be disappointed that it's not performing well. If the data domain is fundamentally different, so if we're talking about computer vision, this could be images that are taken from the air. It could be thermal images. It could be that the sort of images are just like medical images or something like that. All of those would require very specialized handling of those models, even if you do end up using the architecture itself. In text, just so I'm generalizing this, right? So if you're looking at like whatever the internet and Reddit posts, that's very different from medical books or like professional literature and things like that. So you might need or company jargon, I guess. Those are the two examples people like giving. I think all of
Yeah.
those are correct. So it's not trivial to do this. I don't know if you have any concrete tips. Like if someone is like, oh shit, that's me.
Yeah.
How do I deal with this like moving data domain thing? Is there something that you've experienced that could save people time?
Yeah, I would say I will answer it. I think that I wanted to add a bit about what you said is that when we worked with the like drone data, all of those off the shelf models are really like failed totally. And then when we try to use those models on let's say images from the ground, where people taking smartphone images of the trees or the fruits, there it started to work well. Because the data that it was trained on from the beginning, and also the resolution is much more relevant for that. In terms of tips, I would say one of the things that we have achieved is taking satellite data and try and do domain shift to the drone data. So we're taking we can move we can do high super resolution from very very high resolution satellite data, which is like at 30 centimeters per pixel, and move it to drone data. So one of the things there is that in order to do that, we couldn't have like a very smooth like a robust model that we can take the low resolution, bring it to the high resolution of the drone. So what we did, we did this consequently modeling of lower and lower and lower, higher and higher and higher resolution, and then taking a very low resolution satellite and then moving them slowly, training slowly to the high resolution drone. And that way it works much better. So if someone wants to go that way from one domain to the other, I would suggest trying to like finding something in the middle to cut the long way from, if it's a long way to do this model shift.
Interesting. So it's kind of like I don't know. I might be abusing the term here, but it's kind of like a curriculum learning. So you're saying you start with maybe lower resolution, train a bit on that, then jump up to higher resolution until you get to the
Yeah,
resolution that you want. Is that correct?
yeah. It has different names, I guess, but it's mostly helping the model and not just throwing data at it and hoping it will solve every bit of your problem.
Interesting. There's maybe also something to take away from this in that like you're thinking about this from like a real learning perspective. Like if I had to teach someone to
Exactly.
work with this type of data, like how would I build it gradually if they're used to looking at this other type of data? So it's not necessarily like take all of the information and throw it at once, but building it into different classes. I like that. That's a great tip. So I guess we talked a bit about processes and challenges and things like that. Curious, like what tools are you using in this process to manage your machine learning work?
Okay, so I would start with that that as SeeTree grew, we always maintained a very high we did most of the things ourselves. We built most of the tools ourselves. I think that's mostly because the flexibility needed from our customers was really really high, and the pragmatically of the market was really high, and every customer needed a very high modification. So we needed to have our own tools. Most of the things that we have is built ourselves. I will say that right now we're working on top of Google Cloud, which enables us to use tools like Vertex AI, which is our main go-to when we build our own, like the iterations cycling, where we actually take a new data. We want to retrain it, so we're doing data cleaning, then data set generation, then modeling based on different types of architecture, then checking everything. All of this cycle, making sure that the drift is not apparent anymore, and those types of tests. So everything is within this framework of Vertex AI. And also, in order to build our sampling mechanism, which is like the core of what we're working with right now, so we knew that there is like two things that we need to build in order to maintain like a robust way of handling this thing automatically. I think that I want to say that I think that one of the things that represents SeeTree a lot is our state of mind of scale at all times. So we cannot really we don't do anything that cannot be scaled, and in that way we're always building automations for everything. So returning to what I said, we needed automation to handle these drifts, or tools that we can use to handle this drift. So first of all, we did two steps in that way. The first one, in order to represent accurately data, we are training a model unsupervisedly to cluster the entire area, the entire data set, and making sure that all of those clusters are represented. So this is done with deep learning unsupervised models like SWAV. And then what we actually do is in that step, we're just representing what is actually there. But also what we want to do is trying to see if some of those clusters or some of those samples in these clusters are different from what the original model learned from. So this is a second tool that we're using that train a loss prediction. Okay, so we're predicting the loss of the previous model. So once we have this prediction, we actually can say, okay, this specific sample is far from what the original model learned, and it has a very high loss. And because of that, we want to put it in the sample set, and then to see how we actually work, how the accuracy for that. And of course, if it doesn't work, so then we really have good samples to retrain on, because those are far from the data set that the model was working on. And in order to incorporate all of this in a very high scale, those tools are built, first of all, automatically, but then we have some investigative tools that the data scientists were working on. That they get a report, they get data that was out of like distant from the boundary, and then they can analyze this thing in order to say, okay, really this thing is different. This type of data is different from what we know, and then to give some kind of a human intervention in this data science process. So all of those things, although it's, as I said, we want to be fully automated, sometimes we need to acknowledge that things need to have like a very expert human touch, and you need to keep it short but accurately, and then those are the tools that we're building for the personnel in our work.
Amazing. Yeah. So I think that one of the points that that you made, which I very much relate with, is sort of building for scale from day one. I think a lot of times people think about this as like you don't want to do premature optimization, so you don't want to build something that no one is ever going to use. But and I feel this is true for us at Dagzib as well. If you think about some fields, even a sample of like a sample size of one gets you to scale sometimes. So in your case, one customer could have a million trees, you're already at scale. In our case, one customer might have a million images, so we're already at scale. And so a lot of the systems that you have to build from day one are sort of scale in the sense that they have one dimension that you know is going to be high scale from day one, and you need to support it. Otherwise, you're not going to be able to deliver the minimum value. Like you can't go to a farmer that has a million trees in their farm and say, well, we're only going to do this for one tree. Like that's not going to help them that much. So you have to build for that scale. And I like that point about like, you know, trying to automate as much as you can, but always leaving sort of this escape hatch for a human in the loop to review the work being done and make sure that it's actually like representative of what you need. I guess my question then is, would you define this also as the biggest challenge that you have? And if not, like what is the biggest challenge in the machine learning side of things, and how are you solving it, or how do you plan to solve it?
Yeah, I think this. I don't know if this is the biggest challenge, but we're putting a lot of brain power on this thing, and I would say that it's not fully solved in that term. This is why we have like security layers. We have this data science that look at the data, and then we have those samples that we're checking ourselves. Sometimes we add more samples when it's a new domain that we're starting with, new crop or something like this. I think the challenge is bringing automation to this domain at all. And we're maybe at the first steps, or maybe not at the first, but we're not at the end of the road. And there's a lot of things you can do there, and maybe in one day we can also, and those things are something that we're thinking of internally in SeeTree. We can bring some of those things to the customers themselves. For example, if we could give them some tools to do the labels themselves, do the modeling themselves, and bring themselves like a toolbox that can actually bring value without even us in the loop. Just take this system, work with it. So at the vision, we want it to be as like frictionless as possible. So there's a long way to do there.
Mm-hmm.
I think a lot of the things that we're talking about right now in SeeTree is how to do self-serving, enabling our customers to do things by themselves, using, of course, SeeTree's expertise and all the system that we've also already built, and help them maintaining the value that they want with very low cost. Now we believe that this is something that can be done. We are, as I said, we're not at the first step we're not at the end of it, but this is the way, I think, in all in agriculture domain. This is where the world will go. And the customers are getting more and more technology oriented as the young folks are really coming into to play, and we see this trend, and we're trying to get on it.
That's yeah. I was going to ask because your users are also domain experts, and now everyone. I think it's funny. It's like we're reinventing the wheel, but with chatbots and everything, people are talking about collecting product feedback and using that to improve your model.
Yeah,
But that's true for all domains, not just chatbots, of course. So you could basically the internal checks that you do, you can externalize them to the customer and say like, we think this tree is sick. Is this correct? And they need to fill in like answer whatever 50 questions, and then they get a better model. That creates an incentive. You always need to balance though. This is like already a product question, but you always need to balance like what the user expects to be asked and like what they're okay with. Like sometimes the user wants it to just work out of the box. And in another case, they're more willing to invest time if they know they're going to get better results. So I
okay.
think those are all like really good points.
Yes, yeah. I would
Yeah,
also add that you know this AI, those ChatGPT and stuff like this that comes into our life. I would say that let's say a year and a half or maybe 2 years back, when we talked about computer vision models and AI doing stuff, nobody understood us at all. And now, when we're talking to customers, they ask us, "Okay, how does the model work, and how you train it?" And they just did a very like steep learning curve, and that's amazing for us because we're starting to talk the same language. They understand the possibilities, they understand the disadvantages also. So it's a much better world for everybody.
that's actually a really good point. I'm not sure if I heard anyone phrase it that way. Like that the advantage of AI in a different place becoming mainstream is that people understand at some level the concepts behind AI, and so a lot of industries, especially the more traditional ones, now sort of have something coming in that sort of teaches them the terms and the components of the system and everything, and then they can more easily extrapolate to technologies that maybe existed in their field before, but they didn't really understand them. There's just like magic, black box, whatever,
Yeah,
and now it isn't anymore, which is a great tool if you need to educate your market. So
exactly.
that's a huge advantage. I guess taking a step back, a few rapid fire questions before we wrap up. So, what are you personally most excited about in the fields of machine learning and AI?
So I think that I'm really excited right now on all of the domain of simulations, our ability to simulate the real world. This is something that is really critical for the agricultural world. It's really hard to maintain some of the data that we are taking out of those farms. It's really hard to maintain. So, for example, if you want to get the number of fruits on a tree, where it's like let's say avocado tree, which were like has a lot of leaves and it's really hard to count, and no one does this. So if you have this kind of a generative AI simulation, similar to what NVIDIA does with Omniverse and other companies are entering this domain, we will soon be have the ability to simulate the world better, get remote sensing data simulated, for example, LiDAR data and multispectral data. Those things could be simulated, and then you don't need to pay a lot of money to start gathering data out of the real world and get into new application. And this is really exciting from my point of view because it will reduce the bar to enter and help those very hard domains that is really now, let's say someone wants to build a company in the agriculture domain and start flying drones. It's really hard to get into it. So those types of simulation might be really helpful.
Yeah, reduce the barrier for entry and probably unlock a few use cases that were impossible or very, very expensive.
I would say that it's really in the beginning right now. It's really hard to simulate. We did work with few companies that does it, but it's really a world that learns really rapidly.
Yeah. Yeah. Well, it's good to know that we still have something to improve before we get to general intelligence. Uh, Tell me something that you think is true, but that few people would agree with in the field of machine learning and AI. Something maybe more of a hot take.
Uh, I want to say there's a very bad reputation for overfitting. I would say that we're sometimes overfitting is something you can do that can be helpful in some situation where don't have a lot of data and the situation is in some cases really fits it. I think overfitting is something you can do, and people shouldn't curse you that you're trying to do overfitting, but it works and it helps, and it can be a really good solution in some situations. Yeah.
That's a good one. I
Yeah, so
haven't
I
heard
would
that one
say that
before.
it's really. I would say that most of the listeners might say, okay, I can't see any situation where overfitting is better, but I can help you with that finding.
So if you want to hear why when overfitting would be good, then you could reach out to Dole afterward, just so they have
Exactly. Exactly.
reason to. Yeah. I guess so. To wrap up, what are your recommendations for the audience? It doesn't have to be related to data science and machine learning. Anything you want to recommend?
So I wanted to raise like we did talked about this in a point in this discussion, but I think the connection between AI and the neuroscience, uh, which I came from, I had as you said in the beginning, I had my PhD was in the world of neuroscience and AI, and I think having learned those two domains together really helped me understood how much they are really close together, and how much AI can really work as similar to what human works or learns. And we did touched it in a point there. But I would say that anyone that would want to raise their broader their knowledge might go and learn a bit about how people learns, and how the human brain learns, and it will open up your mind a bit on how the machines also can be trained. So that's
That's
my point. Yeah.
that's a great recommendation. Yeah, I think there's a lot of discussions, especially on social media, about whether or not deep learning models work the same way that brains do. But a lot of the people talking about those things don't really know how like brains work, or they have some vague knowledge, but not super specific. So reading about that, like it's all. I think there's a lot of accessible information about that, and so if you feel like this is something that you don't really have a grasp for, at the worst, you can get some ideas on how to think about teaching things, and that could help you build better training loops, even if you don't understand the relationships between a physical neuron and
Exactly.
a digital neuron.
And I would
Yeah.
say, I would even add that if you don't want to read and you want to stay on the technical side, uh, learning and trying reinforcement learning can actually really help with understanding how this works, because there's the reward and punishment concepts there that actually really similar to how human brain works, and how neurons actually converted. So this is like, if you don't want to read boring stories about neuroscience, but you do want to read boring stories about reinforcement, then go.
Awesome.
Yeah.
So I'll recommend one thing that's on topic. If people have not heard this, by the time this episode is out, this is going to be like old news, I guess. But Andrei Karpathy, who you can say a lot of good things about, but recently started his own company called Eureka Labs to focus on teaching machine learning. I think he is one of, if not the best teachers in the field. So if you haven't heard about it, you should check out either his social media or like Google Eureka Labs. There's already one course that they put out that's fully open source and available. And if you're not sure where to start, Andre Karpati's materials are a good place to do that. So that's one recommendation I wanted to make. And with that, Dror, thank you so much for taking the time to speak with me today. There were so many insights here. I'm pretty sure it's going to apply to everyone, no matter what type of machine learning they do. But I really appreciate you taking the time to share this with us.
Thank you for bringing me in. It was really a pleasure.
Awesome. And I'll see you all next time. Bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.